Okay, so number 2 here. We're asked to rotate triangle ABC 90 degrees clockwise about the origin, then reflect it over the x-axis. Okay, so we're going to do the rotation first, then the reflection. And it's important we keep it in the correct order because sometimes it results in a different shape if we change the order. Sometimes it does. Okay? All right, so Eli, to start out here with this, well, I'll wait here. People looks like they're getting some supplies. So go ahead, grab your supplies there, folks. We'll give you some time. Okay. Grab those supplies. Okay, are we ready? Close? I can start, thank you. Okay, so, rotating, 90 degrees, right? That's probably the most difficult one that we do, but let's see here. So, Eli, how do we start out with rotations? What do we do here? Right, okay, so our center of rotation is in a coordinate plane is the origin. All right, we're going to connect A to the origin to the closest point there. And again, it doesn't have to be the closest point. That's just kind of my recommendation to you. All right, so this is the side of our angle we're going to measure that 90 degrees from. And we're going to rotate triangle ABC 90 degrees clockwise. So now we got to think clockwise here. Is that going to be kind of this way to the right or kind of this way down? To the right. Okay, right. A clock goes this direction, right? If you ever get confused about which way clockwise is, look at the clock and follow the second hand. Okay, and the second hand is going to be moving this direction. All right, very good. So we're going to place our protractor on that side, center it at our center of rotation there, like so. Okay, and then we're going to measure. Let's go to, oh, not here. Okay, so Dorian, if I want to measure, okay, this is one side of my angle. So should I use my outer set of numbers that start at 0, or should I use my inner set of numbers that start at 180 to measure here? Should my angle start at 0, or should it start at 180 when I'm measuring it?
I guess you would use the inside one.
So I want to start at 180? Yeah. We don't want to start at 180. No, we always want our angle to start at 0, and then we're going to count up. So it's the 90 right there. There's the 90. We're going to mark off that 90 degrees. Okay. And then draw our angle, our 90-degree angle there, like so. Some of you guys might be able to kind of like eyeball this. I mean, you know, like Mitch was saying earlier, right? A 90-degree angle, so, you know, if we've got this side, well then, the point A here, if we go 90 degrees, it's going to go just to right there, right? You can maybe just kind of see it happen, right? Because it's so close. There's where A is going to go. But again, we'll trace it just to make sure you guys are okay with it here. So we're going to take, now we have the angle measured, we're going to draw in the point of rotation and then our A, B, and C. Okay, and then don't forget to connect those like that. So again, you have those points drawn. Okay. And then Dorian, what do we do at this point? Now that I've got everything traced out, what should we do now? Yeah, exactly. So keep your point O, right? I put my pencil point on point O. That kind of helps me rotate it there. I'm going to rotate until my segment lines up with that other side of the angle, and there it is. Okay, you have to, you know, manipulate a little bit there, but there it is. Okay, so I can see that A has rotated to the point 1, 1. I'm just going to peel my paper back and put a point there at 1, 1. Okay. C, what are the new coordinates for C there, Dorian? Can you see on my, let me zoom in some more for you there. What are the new coordinates for C, Dorian? 4, 2. Perfect. So I'm just going to peel my paper back and put it at 4, 2. And then what are the new coordinates for B? 3, 3. Good. So again, we'll just put our, and we'll label these B prime, C prime, A prime. If you just know the rules, absolutely, just use the rules. Yes, that's fine. Okay, that's fine. Absolutely, it's fine. All right, great job there, Dorian. Thank you, sir. And let's go to... oh, he's not here. Okay, so Colin W. Now we want to reflect over the x-axis. So now we have our shape here. How would you like to reflect over the x-axis? What would you like to do? Yeah, let's just count it, right? The x-axis is right here, and so A prime is 1 unit above, so it will reflect to what? Yeah, just 1 down. So there's where A prime is going to be, right there. Okay, B prime is 3 above, so it will reflect 1, 2, 3 below. There's B double prime. And then C prime is 2 above, so 1, 2 below. There's C prime. Okay, and then there's our final triangle right there. Okay. Now let me ask you a question here. What we did is, again, we rotated triangle ABC to the position of A prime, B prime, C prime. We then reflected A prime, B prime, C prime over the x-axis to get this. It kind of looks here like if I were to just take ABC and rotate it, it would get to this final shape here. Could I just do one rotation to take this original triangle here to the final triangle? Could I just do that in a single rotation? Would that work? I heard no's and yeses. So would it work? So again, if I took my original shape here, triangle ABC, could I get it to be A prime prime, B prime prime, C prime prime using a single rotation? It kind of looks like it, right? If I took this shape and if I just turned it maybe 180 degrees, would that line up correctly? Yeah, let's see here. Let's see. So if I took my original triangle right there, okay, and if I rotate 180 degrees, does it match up?
No.
A does, B does, C does not. Okay, you see that? A does match up, B does match up, but C, because because the orientation changed when we did that reflection, it does not quite match up there. It's close, but it's not. Okay, I mean I can kind of try and manipulate it there, but again, the points just don't match up correctly. You can also kind of see it this way, right? ABC, when it goes around here, it goes A, B, C the other direction. Okay, the orientation of the triangle changes there. So unfortunately, it's not quite right. It's close, but it's not exactly. So we got to be careful with that. Okay? Questions on 2? So we do need, you can't just do that in a single rotation or anything like that. All right. But there is, I think though, let's see here. I think there is a single transformation we could do here though. What single transformation could we do? Eli, what do you see there?
If you make a different line of negatives and then reflect it.
Yes. So if we actually were to reflect this, and I think it's over the line y equals x. So let me show you that. All right. So if I draw the line y equals x, which is this. Okay, well, roughly. I didn't do a great job there. Okay, but anyway, there's the line y equals x. We haven't done a whole lot of reflecting over y equals x, but there's that line. Okay, remember, the line y equals x, okay, if I show you here, y equals x has a slope of 1 over 1, right, and its y-intercept is 0, so it goes through 0, 0, and it goes up 1, right 1, up 1, right 1, and stuff. There's line y equals 1. Now watch this. If I take that triangle, ABC, all right, and I draw that line of reflection there, it's not going to quite work, so I'll just draw it to like the origin, and then I think I should be able to line it up still there. All right, and if I reflect it over that line of reflection, line my arrow back up and the origin back up, look at that. It does match up, okay? So these two transformations can be summarized with a single transformation of a reflection over the line y equals x. Okay? So that's kind of interesting, all right? We can combine them together and create one new, or it can be really just one transformation. We can summarize it in one transformation. Okay. Let's take a look at number 4. Any questions on 2? Questions on that? Okay. So number 4 says, reflect triangle ABC over the x-axis. So that's our first one. then translate by -1, and then rotate 180 degrees around the origin. All right, so let's do that here. So reflecting over the x-axis, let's go to Corey. All right, Corey, to reflect triangle ABC over the x-axis right here. There's the x-axis, right? All right. How do you like to do that? Count it. Okay, great. So where's A going to go to? 2 below, right? So right there. B, where's it going to reflect? 4. Great. 1, 2, 3, 4 down. Okay, B prime. And then what about C? Yep, -5. Good job. Okay. Reflections are kind of nice when you have those horizontal or vertical lines of reflection. They aren't too shabby. Thank you, Corey. All right, let's go to someone we haven't heard from yet. Let's go. Oh, Alex. Well, I haven't called on you yet, I don't think, for to do these. So next one, we're supposed to translate it using this vector. Okay, so that means, what direction is this telling us to go for this vector?
I want us to go, I guess, down.
The -3 there.
3 and -1.
Right. So this -3 tells us to go which direction?
To the left.
To the left. 3. Yep. And what does this -1 tell us to do?
To go down.
Yeah. Great job. Okay. So now we're going to do that. So count, and we can just count it, right? So A prime, just count. 1, 2, 3 to the left, down 1. There's where A prime is going to be. Okay. B prime, count 1, 2, 3 to the left, and down 1. There's B prime. And C prime, count 1, 2, 3 to the left, down 1. There's C prime. Okay, there you go. And so there's the new shape. And then our last one, we're supposed to rotate that new shape 180 degrees around the origin. Okay, and so let's do that here real quick. So there's our origin. Okay, we'll put our patty paper down. Oh, we're going to connect it actually, right? So let's connect it to A prime, right? That's the closest point there. All right. And so then we'll trace that. Center of rotation, A prime, whoop. B prime, C prime. Okay, make that same connection there. Alright. And so rotate 180 degrees. I got to measure 180 degrees. But again, we know 180 degrees is a straight angle. So I'm just going to go ahead and just draw a straight line out there, okay? It's a straight angle. And so then I'll just rotate around to, and there they match up, okay? So Brianna, can you see there? What are the coordinates? Let me scoot it over there. What are some of the new coordinates here then for my point? So for example, this was A prime, this was B prime, and this was C prime. So what's A prime's new coordinate?
4, 3.
4, 3. Yep, so I'm just going to go 4, 3. There it is right there. Okay, and that's A prime. Okay, and what about B prime's new coordinate? What's that?
6, 5.
Yep, 6, 5. Good. I got B prime now. And then finally, what about C prime's new coordinate there? Can you read it okay?
5, 6.
Yep, 5, 6. Pick up sticks, right? C prime. All right. And there's the final answer. Okay, there's the triangle.
Now this is -1.
Mhm.
Have to go left 3, down 1.
Yes. Yeah. The first number in a translation with the vector notation like that, or with the vector written out like this, okay, and its components. The first number, think of it like a coordinate almost. These are your like x coordinates. This is your y coordinates. This is how you're supposed to move in the x coordinate direction, and that's how you're supposed to move in the y coordinate direction. Left 3, down 1. Okay. All right. So the last thing I want to look at here real quick, and then we'll call it a day for this, and we'll get you guys started on the review and things. Okay. The last thing I want to look at, if you turn your page back or if you look into your books here now on the homework and stuff like that, not the homework, the bookwork kind of stuff, they ask us to also kind of like predict. And so what we're going to do here is kind of practice what Mitch was talking about from the warm-up, is just kind of eyeballing these things, okay, and not necessarily doing them, but just predicting using our knowledge here, okay? So we're going to just talk about it too. I'm not going to have you guys write it out, because you can see this is what they wrote out. So the idea is they took triangle LMN here, and they're going to translate it along this vector -2, 3, reflect it across the y-axis, and then reflect it across the x-axis. Notice they don't actually do it here. All they do is they just talk for 4 paragraphs, okay, about how this shape translated, or transformed, I should say. We're not going to do it that much, but we'll still talk about it here. So if you can imagine here, triangle LMN is translated along the vector -2, 3. And so how is that going to kind of affect where this triangle moves to? So let's go to Piper. What do you say here? So this triangle LMN, and again, we're on page 119 for those of you that are looking. Page 119 if you want to follow along in the books, or you can just look up here too, that's fine. Page 119. Okay? So either follow along in your book or just look up here. So, Piper, what's going to happen to this triangle if we translate it using the vector -2, 3? Where's it going to go? Yeah, left 2, up 3. So you can imagine the shape here is just going to move left 2 and up 3. So is it going to change like the quadrant it's in here, Piper? Yeah, no, it's still going to be in what quadrant here, Piper? 2. Yep, this is quadrant 2. I'll number them here for you. So remember, this is quadrant 2, this is quadrant 1, this is quadrant 3, and quadrant 4. Question, Alex?
Because it would go. Oh, never mind.
You're okay? So yeah, left 2, up 3. You're okay with that? Now we're left 2 and up 3, so we're like up in here somewhere right now, and the next thing we're going to do is going to reflect it across the y-axis. Now, Piper, when we reflect this across the y-axis, it's somewhere up in here. Where will it end up? In what quadrant? Yeah, so here's the y-axis. It's going to reflect over to here in quadrant 1. Also, the shape is going to change its orientation, right? Instead of kind of like having LNM, it's going to flip, and it'll be LNM this way, right? It's going to kind of like flip over, so the pointy part will be pointing in towards the y-axis still, but over here in quadrant 1. So now we're like over here in quadrant 1. Okay, good. And then the next step, the third step, is we're going to reflect it across the x-axis. So what quadrant will that end up in, Piper?
4.
Across the x-axis, boom, down here into 4. That's right. So we're down in here somewhere, quadrant 4. Okay, again, changing the orientation of the shape too. And that's it. Okay, that's just kind of like the discussion we should be able to do here. Okay, with those kind of things. So let's turn over here to the next one on page 120, and let's look at this one. Okay, so we now have a square, HIJK, is rotated 90 degrees clockwise about the origin, and then dilated by a scale factor of 2. All right, we won't worry about the dilation just yet, because I don't want to talk about dilations until we get into similarity. Okay, so yeah, we'll just kind of continue with that. So let's go to, let's see here. So Addie, okay, this shape right here. If I rotate HIJK 90 degrees clockwise, so again, we talk about 90 degrees clockwise, and then we talk about our quadrants. There's quadrant 1, 2, 3, and quadrant 4. All right. If I rotate this shape 90 degrees clockwise about the origin, where is it going to end up? In what quadrant? Will it stay in quadrant 1, or will it go to a different quadrant? Quadrant 3, so 9 degrees clockwise. So, sorry, or 4, right. So let's see here. Let's do a quick kind of little sketch. So let's draw a point from K to the center of rotation there, and let's kind of imagine a 90-degree angle. If you need to, you can use a corner of your paper or something like that. So a 90-degree angle with its vertex there, it would kind of be like that direction. That's a 90-degree angle there. So where will it end up? Yeah, 4 and 4. Yep, it's going to rotate around down here clockwise to 4, and it's going to look something like, let's see here if I can figure this out. So it's something like this, I think. Okay, there's that 90-degree rotation. Okay? And then, well, all right, we can talk about this. So, Addie, if we're dilating by a factor of 2, so that means we're taking our coordinates and we're multiplying x by 2 and y by 2, what's going to happen to this shape? It's going to get bigger. And how much bigger? 2 times bigger. Exactly right. All the sides will be twice as big. So here we have a side length of 2, so when we dilate it, we should expect the side length will be what? If the original side length is 2 and we dilate it by a scale factor of 2, so it'll be 4. Yeah, it'll be a 4 by 4 shape. Now here's something interesting. What's the area of this square? 4, right? The area of this square is 4. Now, if I take that shape and I dilate it by a scale factor of 2, like Addie said, we're going to double its size. So instead of having a side of 2, it's going to have a side of 4, and then it'll have another side of 4. So what's a square that's 4 by 4? What's its area? 16. So this had a side length of 2 and a side length of 2, and when we dilate it by a scale factor of 2, it created sides of 4 and 4. But the area was 4, and 16 is not twice 4. It's 4 times 4, right. So there's not exactly the same relationship. So while the sides doubled, right, 2 doubled to 4, 2 doubled to 4, the areas more than doubled. And we're going to look at that later about what the relationship is. There is still a relationship, and Eric kind of, I think it was you, Eric, I heard, right? There is a relationship there for the areas. We'll talk about that later when we get into similarity and stuff like that. All right, so let's look down here at 13, and then we'll stop and give you guys a chance to kind of try this number 14 there. Okay, so let's see here. So let's go to someone we haven't heard from yet. Someone that's here though. Courtney. Okay, so Courtney, rectangle GHJK is reflected across the y-axis. So right now, if I take this shape right now is in quadrant 1 and quadrant 4, right? It's kind of like in both quadrants there. If I reflect this shape over the y-axis, what quadrants will it be in when I reflect it? And here's the y-axis. So what quadrants will it end up in if I reflect it over this line, this y-axis here?
2 and 3.
2 and 3, exactly right. Okay, great, 2 and 3. Now, so you can imagine something like, and actually I can probably draw it real quick here, something like this, right? Okay. Now we want to translate it along the vector 5, 4. So that means which way is it going to be moving? Careful.
Or right.
Right and positive 4.
Oh,
So right and up. So now if we take the shape and we move it right 5 and up 4, where's it going to end up? In what quadrant? Yeah, just in 1. If we move it up 4, it's going to be, so if you look here, 1, 2, 3, 4, it's going to be sitting right on the x-axis. And then, so let's see if I can do this. So 1, 2, 3, 4, 5. So it's going to look something like this. Okay, yes, it's going to look something like this. Okay. And now, of course, this one was easy enough. We could probably have just done it. But great sense there of where the shape ends up. Right there in quadrant 1. Exactly right. Okay. So that's something we want to be able to do. So go ahead, 14. Actually, no, let's not do 14 because it has a dilation, so forget that one. Let's skip to another one here. We'll look at number 7. Number 7 real quick. On page 123. I know we're like jumping all around here. It might be in your homework. And I'll just project it up here. So if you can read it from your seat, feel free to just use the board there. But go ahead and just try number 7. Think about where number 7 is going to end up, or where, how it's moving. And then I'll call in some people here. So just take a look at number 7 real quick, and then we'll just kind of review for the rest of, or I'll have you guys work on the review for the rest of class. So take a look at this, please. Take a look there and see what you think. So number 7, again, you're translating triangle ABC along the vector -3, -1. Excuse me. You're going to reflect it across the x-axis and then reflect it across the y-axis. So think about how that's going to go. You don't actually have to do it. In fact, I want you to just practice, like Mitch said, eyeballing. Okay? Just think about where it's going to go. If you want to, do it, feel free to actually do it. But or you can try to give it a help or something like that. Okay, this is just kind of estimating right now. Think about how it's gonna move. So I think you first wanted to do the vector, right? It's translated along the vector first, then reflect across the x-axis. You did the reflection first, and then you translate. we didn't translate first. That's okay. Just make sure you keep it in the right order, because you know that can change the shape sometimes, right? We have to do it in the order that we're given it, because sometimes it can change how it looks. Yeah. Well, good question. So, for example, just think about it in terms of the points. Where will A end up if you reflect across the y-axis? Right. So A is 1 unit to the left, right? So then, exactly. Now B, though, is 1 to the right, so it will go, there you go, see, exactly right. Just focus on the vertices, don't try to focus on the big shape. Just focus on the points of the shape. All right. Let's see here. So, let's go to Curtis. All right, so Curtis, the first thing, translating triangle ABC along the vector -3, -1. How's that going to move our shape? Yeah, left 3, down 1. Exactly right, okay? Now, if we move this shape left 3 and then down 1, is it going to be in one quadrant? Yeah, it's going to be kind of like in 2 quadrants there. I think it'll be like it's kind of split between 1 and the 2 there. So good, though, that's right. So we're like kind of sitting like right in here somewhere, okay? And then we're going to reflect it across the x-axis, and so where's that going to make it end up then? Yeah, I guess so, huh? Yeah, so reflect it down, boom, it's going to be like here, 4 and 3, changing the orientation too. And then we're also going to, so like we're right here right now. And then we're going to reflect it across the y-axis. So just kind of do this, right? So it's still sitting on top of that y-axis there because the shape was kind of, the y-axis going through that shape. It's going to have something like that. And in fact, I can show it to you real quick because it's so, this one's not too bad. It's going to left 3, down 1. So left 1, 2, 3, down 1. So there's A prime. And then let's see, B is going to be right there. And C will be right there. Okay, so there's your prediction, right? Both quadrants, you were right. Reflected across the x-axis. So there's that, and there's that. Okay, so there it is reflected across the x-axis, and they're going to reflect it across the y-axis. So this point's 2 to the right, it will reflect 2 to the left. This one's 1 to the left, it will reflect 1 to the right. 1 to the right, reflects 1 to the left. And so there's our final shape right there. So you can see it's kind of like split over. Okay, and again, this is a rough sketch because it's just asking us to estimate, not estimate, but to kind of describe what's going on there. Good job there, Curtis. Very good. All right. Questions on that? Yes.
Okay. When I reflected it, I thought you were like try near like the 3rd quadrant. So when I did that because the B, I reflected it over to like the mid or the
Let me come take a look at it, Alex, because I'm having trouble visualizing it. But everyone else, so I'll come do 1 second. I'll be right there with you. Everyone else, if you guys would please, I gave you that review paper yesterday. If you weren't here yesterday, I'll get you the paper right now. But I gave you the review paper yesterday, so you can start working